Hi friends, welcome back to Networks. So in our last lecture we saw about the VXLAN flood and learn and VXLAN ingress replication static. So today we are going to see about the VXLAN BGP-EVPN. So what's the difference from the ingress replication, flood and learn and BGP-EVPN? So ingress replication basically uh, it what are the broadcast we receive it converts it as a unicast. So what happens, like, the every broadcast ARP request will be made as a multiple copies to the multiple VTUPs in the unicast format. So it's going to be a overhead for the VTUP devices. Also, it's merely impossible if you have 100 leaf switches, keep adding the VTUP address on all the 100 devices statically. So 100 into 100, so many static entries you are going to add it, keep adding it, the data center keep growing, and the static configuration keeps getting added to it. So to overcome that, it has come up with the flood and learn now. So the flood and learn is basically it works with the multicast, and every ARP request, the broadcast request reaches the leaf switch, and it will be sent to the multicast, sent as the multicast flood across the fabric. So this is based on the multicast address you map it for that particular VNI. So the steps are, you just create a VLAN. For that VLAN, you map a VNID. For that VNID, you map a multicast address. So it basically works on the multicast from the flood and learn environment, which we saw it in the last lecture. I can give you the multicast links in the description, multicast and ingress replication in the description. You can just go through that and give us your feedback on that. So now, what is the how the MPBGP helps the VXLAN in that? So first, let's see about what is very short description about what is MPBGP. So MPBGP is the just a multi-protocol BGP. So why it helps the BGP? So we have multiple address family. Let's say for an example, IPv4, VPNv4, and IPv6. So for each and everything, we cannot go for multiple BGP peerings, right? So to in a single peering, we need to allow all the address families into the BGP. That is what the MPBGP has come into the picture now. So now he to advertise the here in the VXLAN, the MPBGP is used as a control plane protocol. So it, ideally speaking, it's going to advertise the MAC address from the one VTUP to other all other VTUPs in the fabric. So S- to advertise this, there is a something new attribute called EVPN. So which is the EVPN is a community where it advertises the it can carry the MAC address information between the VTUPs. So here in this, the spines are going to be acting as the route reflector, and the leaves are going to be the route reflector client for those spines. So since this is the completely layer 3 on the between all the connectivity is going to be a layer 3, the underlay will be the OSPF, and we are going to configure the BGP overlay, so on top of it, so over the loop back. Okay, let's jump into the lab right now. So we have two spine switches and leaf switches. For easy management, I have connected to my management network, which is the management cloud in the Eve, so that I can access them directly from my LAN. So I have assigned for 9K1 as a 91, 92, 93, 94, which is the 9K1 and 9K2 are the spine, and 9K3 and 9K4 as the are the leaf. So I already configured the OSPF and IP address, everything is done. Also I have configured the uh, multicast. So you can ask, why do we need a multicast? So every first packet is still going to be the multicast. I mean, the broadcast ARP request will still will be on the multicast, and consequent packets, once the other VTEP learns the MAC address, it will be advertised over the BGP to all other VTEP. So what we avoid is the whatever the VTEP learns, we don't, ideally speaking, we don't keep looking up for the ARP request. So let us start. Okay. So what is, okay? I lost the 93. Let me log in. So they get timeout. Okay. Fine. So config T. Let's enable the feature. Feature BGP. Feature. This is going to be fabric forwarding, and NV. I don't think. Yeah, we need NV overlay. I'm sorry, NV overlay EVPN. These are the features we required. And on 9K2, we are going to enable the same feature BGP. Okay, NV overlay EVPN feature. What else we enabled over there? Feature BGP. Feature fabric forwarding. Fabric forwarding. Let's go to 9K3. Here, let's enable feature BGP. I'm sorry, config T. Feature BGP. Feature fabric forwarding. NV overlay EVPN. This is to enable the EVPN address family, and then feature. Remember, this is the sleep switches where the VXLAN encapsulation is going to happen. So feature NV overlay NV. So which is, we are going to enable the NV interface on it, overlay interface on it, right? So then feature VN segment VLAN base. So we are still going to do the VXLAN to VLAN map. Sorry, VLAN to VXLAN mapping. Okay. So next, let's go into NK spine. Sorry, leaf 2, which is NK4. Here, let's enable what all the features here. We'll enable here. Okay, sure, and pi feature. So I've already enabled VoicePF and PIM. Still, nothing wrong if I copy paste it. So it makes the things easier. Okay. Then moving forward, let's start the configuration with the BGP config T router BGP 12345, and we'll configure the router ID as the loopback 0 address. So run interface loopback 0. This is going to be 10.9.9.1, which is 9K1. So router ID 10.9.9.1 and neighbor. So we need to configure our leaf switches, not the spine switches. There should not be BGP peering between the spine. So rather than we'll be having a neighborship relationship with the all the leaf switches. So neighbor 10.9.9.3 and remote AS going to be 12345. So it's all going to be the IBGP peering. So since this is IBGP peering, so a route received from IBGP peer cannot be sent to the another IBGP peer. To overcome it, we are configuring the route reflector, and not only that, always it's recommended to run the route reflector in the full mesh. So this is going to be kind of a full mesh. Update source. So this is going to be loopback. Source does a loopback. So update source loopback. Then let's get into the address family. Address family L2 VPN, EVPN, send community both. So this is where we are trying to send all our communities, and let's configure them as a route reflector kind. Okay, let us copy paste this. Let's configure the other leaf. Let me take out the configuration. Router BGP 12345. Then we configure the leaf 2, and all others are going to be the same. Then let's configure the spine 2 switch. So let me paste it in a notepad, and I do make it easy for you guys. So we just need to change the router ID of it. So router BGP 12345. So we will be configuring same two leaf switches as their BGP-PS. So let me go through what has been configured. So run section BGP. So same thing, we have made that route radius 9.9.2, the neighbor, the leaf 1 which is 9K3, and the leaf 2 which is 9K4. So remote AS updates us loopback L2 EVPN, and since this is going to act as a route reflector server, so we are configuring as a route reflector client. Same way for leaf 2 which is 9K4, and whatever the configuration over there on the spine one, we are configuring it here. So coming to the 9K3, let me paste this configuration, edit it, and make it easy. So let me create the configuration on screen. Router ID is going to be .3, and the neighbor is going to be .1. We are going to remove the router reflector client. Neighbor is going to be .2, and we are going to remove the router reflector client. 9K3 router 1 2 3 4 5. Sorry, router BGP 1 2 3 4 5. Copy, and we are done with the. Then let's go for 9K4 config T router BGP 1 2 3 4 5, and let's change the router ID and configure the same. It's going to be the two spines again, the same, no changes in it. Okay, I'm sorry, somewhere it got missed out. So I think we have not enabled the feature NV overlay here. So let's enable the NV overlay, NV overlay EVPN. So let's paste the same thing now, because until unless we enable the EVPN, you will not be able to configure the address family L2 EVPN. So router BGP 12345, then yes. we are finally succeeded. I would say if we go and give show IP BGP summary, let's try it. You won't see it because we have enabled the BGP under the EVPN. So show BGP summary, show BGP L2 VPN, EVPN summary, then we should be able to see the BGP peers established. We have done with the BGP configuration. Now we are going to first to configure the multicast stuff part. So we are going to make the create a new loopback on the spine one, and we are going to create the RP address on it. Show run interface loopback 0, and there is no loopback 1. Let's have a look. Okay, interface loopback 1, IP address 192.168.10.1 slash 32, and IP router OSPF 1 area 0.0.0. So ensure this is advertised IP PIM sparse mode. I'm sorry, IP PIM sparse mode. So let's configure IP RP address, IP PIM RP address, going to be the IP 192.168.10.1 bidirectional. For the group list 228.0.0.0 slash 24 bidirectional. So this is going to be there for all the devices. Let's configure the same for all the devices so that we enabled multicast on this. Let me configure. Okay. Now, if we go ahead and see show IP M route, we should be able to see there is an star comma G created for 220.0.0/24. Once we are done with the multicast configuration, we may need to configure the VLANs. So let me configure VLAN 100 and do a VNA mapping. I'm sorry, not on the spine switches. Let's go into the leaf 1 and leaf 2, 9K3, and so where this is going to be having the VLAN to VNID mapping, VN segment 10100. Okay, then go into this VLAN 100 VN segment 10100. EVPN, enter. So we have enabled into the EVPN. So VNI 10100, then VNI 10 L2. Okay. So here this is the configuration where you do route, target, import, export, and you assign the RD value for it. This is the command equivalent to in our traditional VPN v4. We get into the VRF. Let's say we get into the VRF name, and we give the RD and RT values, right? So same way for the VXLAN, we go into EVPN. Under that EVPN, we go into that particular VNI ID, and inside that VNI you are going to configure the RD and RT value. But there is a small difference here from the normal traditional MPLS to L3 VPN to the VXLAN VPN. So here we are not going to assign. You can assign a static RD values and RT values, but still we are not going to do that. So this has been given with much more flexibility to automatically generate the RD and RT value from the VNI. So we are going to give RD auto. Let's see why this is not getting generated. So VLAN 100 is there and active, and Ethernet 1/3 is there. So this should have been generated. VNI RD auto. Yes, it has taken. I don't know what is the reason behind. Initially it did not take. We did not do any modifications. However, it taken it right now. Okay. Route target, and route target is going to be for exporting and importing the RT, so the value over the VPN community. So let's configure route target both auto. Okay, so we can see this what is the RD value and got generated in the BGP table after we advertise them. Okay, so let's now jump into 9K4 and do the same configuration. Now we have done the VLAN to VN segment and go into EVPN. Once they enter into the EVPN, now let's configure VNI 10100 L2. I'm sorry, L2. So in this we configure RD auto and route target. It takes some time, I guess so. Unable to generate no VNI configure. Yes, it takes some time after the VNA command. Route target both auto. Now it's done. Now it's time to configure the NVE interface. Let's interface NVE1 source loopback 0 member VNI 10100 MCAS group 228.0.0.100. So we configure 100 as since we use the VLAN 100, then enter. Then we are going to configure host reachability protocol as a BGP. This is where we are going to make this act as the BGP as its control plane. So let's first, before that, let's give show NVE interface. It's going to it's going to be down. However, show NVE one zero one zero zero. If you it is going to be down, I know it, but it is in the mode of data plane because this is into the flood and learn mode. So let's configure the host reachability protocol going to be BGP. The moment you configure this host reachability protocol BGP, the moment we configure this, if we see the output of show NVVNA 10100, it is going to be the mode of control plane. So now the BGPs act as the control plane. Let's do the same thing here. Interface NV1 source interface loopback 0 member VNI 10100 my MCAS group 228.0.0.100 host reachability protocol BGP. So NVE VNI 10100, it is still down. So NVE interface. So let's shut and unshut the NVE. I think we should have issued a no shut command. No shut. Yes, they are up now, and we should expect the both the devices should be able to ping. The VPC1 and VPC2 should be able to ping each other. So let's get into that VPC. The IP address of the VPCs have been already configured. Okay. So before that, let me initiate a capture from leaf capture Ethernet 1/6. I have got the VPC2 with me. This is a VPC1. Show IP. So 1.2 has been configured here and 1.1 has been configured here. Okay. So we have started the capture. We could see there are a few CDPs, BGP, OSPF updates are keep going within that. Now let's ping 1.2. Yes, we are able to see the reply. And if we go into the spine, let's see the capture. I think the ARP has already gone. Yes, the ARP has already gone, and this has already advertised to the other leaf. Okay, so no, not a problem. I can show you the BGP table on it. Let's see on the leaf. Show BGP L2 VPN EVPN. So now we can see what is the route distinguisher got generated. It is IPS IP colon the some unique number. So 10.9.3 colon 32867. So this is the route distinguisher got generated, and you can see the MAC address which is getting advertised in that. So it's all going to be from now. It's not going to refer the MAC address table, rather than it's going to refer the BGP table, where since it is a control plane, it's going to refer the BGP routing table. Show BGP L2 VPN EVPN EVPN summary. So we can see one prefix is getting received from both. So we are done with the BGP EVPN configuration. Now next we are going to see about L3 VNI. So till now we saw everything. Whatever we saw is L2 VNI. The L2 VNI is again called something like we are communicating. We are having a two hosts within the same VLAN on two different switches, and you stretch your VLAN across the switches and get the reachability. So same way we have a L3 VNI for the two different subnets to communicate to each other. So we are going to have the L3 VNA gateway and get them routed between these two different subnets. For this, we need the BGP to be configured. So in our next class, let's see about L3 VNA. Probably next week we can meet up. Thank you very much for watching, and please subscribe and share this. And please let us know your feedback on this. Thank you.